To calculate residential service load easily, a program has been developed. Instructions are as follows. Firstly, download the program file from the provided link. Secondly, open the downloaded file in a spreadsheet application such as Microsoft Excel or Google Sheets. Thirdly, enter the following information into the designated cells: number of bedrooms, number of bathrooms, square footage of the home, number of occupants, and customer type, indicating either family or individual. The link to the program file is provided. The program utilizes a formula to calculate the service load. The service load equals 0.5 times the number of bedrooms plus 0.75 times the number of bathrooms plus 0.5 times the square footage plus 0.1 times the number of occupants plus 0.25 times the customer type, with 1 indicating family and 0 indicating individual. The program will then display the calculated service load in a dedicated cell. Additional notes to consider are these. The program assumes the home has standard amenities such as a kitchen and living room. The service load represents the estimated number of hours of cleaning required per week. Adjust the calculation parameters as needed to suit the specific needs of your business. It is important to understand the fundamentals of electrical service calculations for residential buildings. These calculations determine the appropriate size of the electrical service, ensuring it can safely and reliably supply power to all connected loads. The National Electrical Code, or NEC, provides the guidelines and methods for performing these calculations. The service load calculation involves several steps, including determining the general lighting load, appliance load, heating and cooling load, and any other specific loads, such as electric vehicle chargers or large appliances. The general lighting load is calculated based on the square footage of the dwelling. The NEC specifies a minimum lighting load of 3 volt-amps per square foot. This value is then multiplied by the total square footage of the dwelling to determine the total general lighting load. For example, a 2,000 square foot home would have a general lighting load of 6,000 volt-amps. Appliance loads are divided into 2 categories: small appliance branch circuits and individual appliance loads. The NEC requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas. Each of these circuits is rated at 1500 volt-amps, resulting in a total small appliance load of 3000 volt-amps. Individual appliance loads, such as refrigerators, dishwashers, and washing machines, are calculated based on their nameplate ratings. The nameplate rating indicates the maximum power consumption of the appliance in volt-amps or watts. If the rating is in watts, it can be converted to volt-amps by dividing by the voltage. For example, a refrigerator with a nameplate rating of 500 watts at 120 volts would have a volt-amp rating of 500 divided by 120, which equals 4.17 amps. The heating and cooling load is typically the largest load in a residential service calculation. The method for calculating this load depends on the type of heating and cooling system. For electric heating systems, the load is calculated based on the total wattage of the heating elements. For air conditioning systems, the load is calculated based on the nameplate rating of the air conditioner compressor. The NEC allows for demand factors to be applied to certain loads, which reduces the overall service load calculation. Demand factors account for the fact that not all loads will be operating at their maximum capacity simultaneously. For example, a demand factor of 100% is applied to the first 10 kilowatts of heating load, and a demand factor of 40% is applied to any heating load above 10 kilowatts. After calculating all the individual loads, they are added together to determine the total connected load. The total connected load is then multiplied by any applicable demand factors to determine the service demand load. The service demand load is the amount of power that the electrical service must be capable of supplying. The size of the service entrance conductors and overcurrent protection devices is determined based on the service demand load. The NEC provides tables that specify the allowable ampacity of different sizes of conductors. The ampacity of the conductors must be equal to or greater than the service demand load. The overcurrent protection devices, such as circuit breakers or fuses, must also be sized to protect the conductors from overloads and short circuits. The service entrance equipment, including the service disconnect and metering equipment, must be rated for the calculated service demand load. The service disconnect must be capable of interrupting the entire service load in the event of an emergency. The metering equipment must be able to accurately measure the amount of energy consumed by the dwelling. In addition to the general service load calculation, there are also specific requirements for calculating the load for electric vehicle chargers. The NEC requires that electric vehicle chargers be considered a continuous load, meaning they are expected to operate for 3 hours or more at a time. The load for an electric vehicle charger is calculated based on the output current of the charger. For example, a 40 amp electric vehicle charger would have a load of 40 amps times 240 volts, which equals 9,600 volt amps. The service load calculation must also take into account any existing loads on the service. If the dwelling already has an existing electrical service, the existing load must be added to the new load to determine the total service load. The existing load can be determined by reviewing the utility bills or by performing a load study. A load study involves measuring the current flowing through the service conductors over a period of time to determine the maximum demand. The NEC also provides guidance on calculating the load for multifamily dwellings. The load calculation for multifamily dwellings is similar to that for single-family dwellings, but there are some additional considerations. The general lighting load is calculated based on the square footage of each dwelling unit. The appliance load is calculated based on the number of dwelling units and the types of appliances installed in each unit. The heating and cooling load is calculated based on the type of heating and cooling system used in the building. The NEC allows for demand factors to be applied to the general lighting load, appliance load, and heating and cooling load in multifamily dwellings. These demand factors account for the fact that not all dwelling units will be using their maximum amount of power simultaneously. The service load calculation for multifamily dwellings must also take into account any common area loads such as lighting, elevators, and laundry facilities. These loads are added to the total load for the dwelling units to determine the total service load. The service entrance conductors and overcurrent protection devices must be sized to accommodate the total service load, including the dwelling unit loads and the common area loads. The service entrance equipment must also be rated for the total service load. In addition to the NEC requirements, local codes and regulations may also apply to residential service load calculations. It is important to consult with the local building department or electrical inspector to ensure that the service load calculation complies with all applicable requirements. Accurate service load calculations are essential for ensuring the safety and reliability of residential electrical systems. Undersized electrical services can lead to overloaded circuits, overheating, and even fires. Oversized electrical services can be more expensive to install and may not operate as efficiently. By following the NEC guidelines and consulting with qualified professionals, it is possible to perform accurate service load calculations and ensure that residential electrical systems are properly sized and protected. Understanding the principles of service load calculations is crucial for electricians, electrical engineers, and anyone involved in the design or installation of residential electrical systems. A thorough understanding of the NEC requirements and the factors that influence service load calculations is essential for ensuring the safety and reliability of electrical systems. The program mentioned simplifies this process by automating the calculation based on key inputs. By entering the number of bedrooms, bathrooms, square footage, occupants, and customer type, the program provides an estimated service load. This estimate can then be used as a starting point for further evaluation and refinement, ensuring that the electrical service is adequately sized for the specific needs of the residents. While the program offers a convenient way to estimate service load, it is important to remember that it is only a tool. The accuracy of the calculation depends on the accuracy of the input data and the assumptions made by the program. It is always recommended to consult with a qualified electrician or electrical engineer to perform a comprehensive service load calculation and ensure compliance with all applicable codes and regulations. The NEC provides detailed guidelines and methods for calculating service loads, and a qualified professional can help navigate these complexities and ensure that the electrical system is properly designed and installed. Furthermore, it is important to consider future load additions when performing a service load calculation. As technology evolves and lifestyles change, the demand for electricity in residential buildings is likely to increase. Electric vehicles, smart home devices, and other new technologies can significantly add to the electrical load. Therefore, it is prudent to plan for future load additions when sizing the electrical service. This can be accomplished by adding a safety margin to the calculated service load or by installing a larger service than is currently required. By planning for future load additions, homeowners can avoid the need to upgrade their electrical service in the future, which can be a costly and disruptive process. In addition to the factors mentioned above, it is also important to consider the diversity of loads when performing a service load calculation. Diversity refers to the fact that not all loads will be operating at their maximum capacity simultaneously. For example, the air conditioner may not be running at full capacity on a mild day, and the electric vehicle may not be charging at its maximum rate all the time. The NEC allows for demand factors to be applied to certain loads to account for diversity. Demand factors are based on statistical data and reflect the likelihood that a particular load will be operating at its maximum capacity at any given time. By applying demand factors, the calculated service load can be reduced, resulting in a more efficient and cost-effective electrical system. However, it is important to use demand factors judiciously and to ensure that the calculated service load is still adequate to meet the actual demand. The service load calculation is a critical step in the design and installation of residential electrical systems. By following the NEC guidelines, considering future load additions, and accounting for diversity, it is possible to perform accurate service load calculations and ensure that electrical systems are properly sized and protected. The availability of programs like the one described can simplify the process and provide valuable insights, but it is always recommended to consult with qualified professionals to ensure compliance with all applicable codes and regulations and to ensure the safety and reliability of the electrical system. Residential service load calculations are more than just plugging numbers into a formula. It's about understanding how a home uses electricity and planning for its future needs. Think of it like this: the electrical service is the highway that brings power to your home. If the highway is too small, there will be traffic jams or power outages. If the highway is too big, it's a waste of resources. The goal is to build the right size highway for the traffic it needs to handle. That traffic is all the electrical stuff in your home: lights, appliances, heating, cooling, and all the gadgets we rely on today. Firstly, the NEC provides a detailed roadmap for calculating this traffic. It starts with the basics, like the square footage of the home. Every square foot needs a certain amount of power for lighting and general use. Secondly, then come the appliances. Big ones like refrigerators, ovens, and washing machines each have their own electrical appetite. The NEC tells you how to account for these individual loads. Thirdly, heating and cooling systems are often the biggest power consumers at a home. Calculating their load accurately is crucial. The NEC provides different methods depending on the type of system. Then there are the smaller appliances, the ones plugged into the wall. The NEC requires a minimum number of circuits for these, ensuring there's enough power for everyday use. Remember demand factors: these are like traffic lights that help manage the flow of electricity. They recognize that not everything runs at full power all the time. For example, you might not use all your lights at once, or the air conditioner might not run constantly. Demand factors allow you to reduce the calculated load, making the service more efficient. But be careful not to underestimate the load. It's always better to err on the side of caution to avoid overloads and potential hazards. Another important consideration is future expansion. Are you planning to add an electric vehicle charger, a hot tub, or a home office? These additions will increase the electrical demand. It's wise to factor in future needs when sizing the service. Finally, don't forget local codes and regulations. They might have additional requirements or restrictions. Always check with your local building department to ensure compliance. In conclusion, residential service load calculations are a blend of science and art. It requires a thorough understanding of the NEC, careful consideration of individual loads, and a forward-thinking approach to future needs. The program mentioned in the initial response is a helpful tool, but it's not a substitute for professional expertise. Always consult with a qualified electrician or electrical engineer to ensure a safe and reliable electrical system for your home. Electrical safety is paramount. Overloaded circuits can lead to overheating, fires, and even electric shock. Properly sized service entrance conductors and overcurrent protection devices are essential for protecting your home and family. Never attempt electrical work unless you are qualified and experienced. Electricity is a powerful force that demands respect. Always follow safety precautions and consult with a professional when in doubt. The electrical system is the heart of your home. Keeping it healthy and functioning properly is essential for modern living. By understanding the principles of service load calculations and working with qualified professionals, you can ensure a safe, reliable, and efficient electrical system for years to come.